Didn't know already, Madison Blockchain is a meetup group focused towards educating community members in the Madison Greater area to learn about blockchain and get involved in the ecosystem. So today's presenter is Connor Murray. He's also a member here. Today we'll be talking about Bitcoin Cash and kind of go back in the history of how Bitcoin Cash actually started and how it evolved. Talk a little bit about the debate between the Bitcoin block size, and then talk about what's ahead in Bitcoin Cash's roadmap. So I'll let Connor introduce himself and take it from here. Thanks.
Yeah, I'm Connor. So I'm going to be talking about something I'm pretty passionate about, Bitcoin Cash. So very briefly, why I'm here. I first began reading about Bitcoin back in 2013. I was in calculus class and I was reading about the Silk Road, which I didn't have interest in necessarily, but basically what that was an online drug marketplace. People were using Bitcoins to buy and sell drugs and various other things, nefarious things, I guess. So really my first introduction to Bitcoin was seeing it in use in commerce on the internet. And then today I'm working on a variety of different things Bitcoin Cash related. You can ask me more about that later. But so every presentation I go to, usually it starts with saying, because blockchains can't scale, then this. And I'm going to challenge that. So I'm going to say, why not? Why can't blockchain scale? And in particular, Bitcoin. So if you don't know what Bitcoin is, it's a peer-to-peer electronic cash system. Lets you send money instantaneously, basically for free. It was created in 2009 with the Satoshi Nakamoto white paper, who's an anonymous person or group. So there only ever is going to be 21 million Bitcoins, so it makes it a deflationary currency, which is very attractive. You can't just print more Bitcoins out of thin air. And also it's an open source development project, so anyone can contribute to Bitcoin. And if you look back through its history, a lot of people have done a lot of really cool things for it, most of the time for free. So why Bitcoin? Why would you use Bitcoin? I don't know kind of the level of understanding people have about Bitcoin in general here, but I am going to kind of skip through it and definitely stop me if you have any questions. But basically the reason why Bitcoin is really powerful is it allows you to transact with anybody across the globe without permission from a third party. So that's very important because in the case of restricted governments, they can prevent you from trading across borders. In the case of even just banks are very hard to deal with. You know, I mean, I'm sure everyone here has had their bank decline a transaction before, and you have to call them up, whatever else, which is kind of ridiculous. Really, Bitcoin is the greatest tool to expand economic freedom to the globe. And that's why I'm passionate about it. And in general, I think one of the big examples if you go on the internet and you see anybody taking Bitcoin or any kind of cryptocurrency, it allows you to tip the money instantaneously. It allows just a very free exchange of value across the internet. And that's definitely the future of money. It's just a matter of which one will it be, I guess, or maybe it'll be many of them. And so that's why I want to talk first, like what makes good money. And there's three kind of things that really boil down to what is good money. Number one has to be a good store of value. So in the case of any kind of asset that's very volatile, it's not necessarily a good currency. You don't want to, if something is worth 5 Stanley nickels one day and then it's 3 the next day, that's not a very good currency. You're not sure as to how much your Stanley nickel is actually worth, right? So I put immutable, secure, because really, in the case of gold, for example, gold is very durable. Just in general, money has to be a good store of value. The second is it has to be a good means of exchange. So it has to be divisible, fungible, and easily transactable. So that's why cash is very obviously useful. You're allowed to, you can hand out dollar bills, $20 bills, whatever else. In the case of gold, gold was actually gold is very divisible. So that was one of the big reasons why gold became a currency itself in a way. And really the last thing about good money is that goods become denominated in that currency. So in the case of Bitcoin today, no matter Bitcoin Cash, really you're not going to go online and find a lot of marketplaces selling things in respect to Bitcoin, unless trying to exchange or things like that. And really historically, a good currency has always been something that you can go and someone is willing to take that for a good, right? And historically that's been rice in some places. That's been a lot of different things. So what made Bitcoin valuable? So Bitcoin at one point in December was worth $20,000. I'm sure that got a lot of people's attention. Maybe that was the first time somebody had ever heard of Bitcoin, anything like that. What made Bitcoin valuable to begin with, though, was commerce. So in the case of things like the Silk Road, things like online drug marketplaces, that was a way for people to actually transact with Bitcoin. And historically, there has never actually been a store of value that wasn't a good means of exchange. So the only example that you can actually come up with historically, and there might be a few others, but this is the most well-known one, is people actually used to have stone blocks that they would put on their front step. And these giant stone blocks became how you would measure your wealth. The problem is that they were impossible to move from one house to another. So if you actually were transacting in values of the stone block, people would start writing IOUs, right? And that's kind of dangerous, right? Because you're just saying, I owe you half this stone block, and then he owes me half his stone block, and whatever else, right? So the question really comes down to, and this is really the big debate in the Bitcoin Cash world, is can you have a store of value without a means of exchange? I would say no. Open for debate, I guess, but the last question I want to ask for, I'll address these questions a little bit more in depth. In a market of altcoins, is Bitcoin actually deflationary? So that's another big question. So things like the Lightning Network, whatever else, will have atomic swaps for other cryptocurrencies. So if I can print 8 billion tethers, for example, and your Bitcoin is tied to my tether, is Bitcoin actually deflationary when it's tied directly to an asset that can be controlled at will? And that really, I think, flies in the face of what made Bitcoin valuable to begin with, because it's a deflationary asset over time. If it's immediately swappable and in some ways no different from another digital asset that can be inflated at will, I really do believe you destroy the deflationary aspect of Bitcoin. So, Bitcoin, when it was created, is a peer-to-peer electronic cash system. This is the abstract of the white paper. You can even read, I'll read just the first few sentences. A purely peer-to-peer version of electronic cash would allow payments to be sent directly from one party to another without going through a financial institution. Digital signatures provide part of the solution, but the main benefits are lost if a third party is still required to prevent double spending of money. So this is how it was introduced as a peer-to-peer electronic cash system. Bitcoin is not, to me, a digital store of value only. It is not a settlement layer, and it is not an ICO for the Lightning Network. That, to me, is what I believe. I don't understand where we went from electronic cash system to here. But luckily, it doesn't really matter, because now we have Bitcoin Cash, and we have Bitcoin, and both sides got what they wanted, so I'm happy. So we'll start with just a devil's advocate slide. I borrowed this, but I think it's a really good way to start here and kind of work backwards. I guess, has everyone heard of Bitcoin Cash before today? Was this kind of the first introduction or whatever else? The biggest thing that you read online is Bitcoin Cash is a scam. Does anyone think that? You're allowed to think that, maybe? So that is one criticism, that Roger Ver himself created Bitcoin Cash to get even more rich and whatever else. There's not much I can do to convince you that's not true. And in fact, with Bitcoin, so when Bitcoin actually forked away, or Bitcoin Cash forked away from Bitcoin, there were no coins introduced. There was nothing else. It was just everyone that owned Bitcoin also now owned Bitcoin Cash. So as far as forks and altcoins go, it's pretty far away from a lot of the scams you actually do see out there. The next argument would be it avoided SegWit to use ASIC Boost, which ASIC Boost is essentially a patented technology to get more out of your miner. I disagree with this one quite a bit because, number one, now there's a version of ASIC Boost being used by Slushpool with SegWit. I don't really know too much about it, but on the other hand, I also don't think, I would say two things about this. Number one, there's a lot of other reasons to oppose SegWit, in my opinion. And then also, I actually don't see anything wrong with ASIC Boost, but that's a debate for another time. Bitbox lead to centralization. That one I'll address further on in this presentation. I think that is a valid concern if you are worried about nodes becoming centralized. But I also think Satoshi addressed that very clearly in the beginning of Bitcoin's history. Lightning Network will make Bitcoin Cash useless, possible. I'll talk about that as well. I don't think it will. It's less secure, it's vulnerable to 51% attacks because there's less hash rate on Bitcoin Cash. So right now, Bitcoin Cash has about 1/10 the hash rate of BTC. So if miners really wanted to, they could attack Bitcoin Cash relatively easily. That's also, I think, a valid concern. If there's a ton of S9s that want to attack Bitcoin Cash, it definitely could happen. It's not Bitcoin, it's an altcoin. I think that this is where a lot of people, like the big fiery debates come from. Like a lot of people on the Bitcoin Cash side say, no, it's Bitcoin, and Bitcoin is something different and whatever else. In the interest of not confusing people, I'm not going to be that guy. I will talk about Bitcoins in the presentation, but what I really mean is like spending Bitcoins. Because to me, the actual coin itself is the same between two chains. You just have different UTXO sets and whatever else. So I think Bitcoin Cash has a claim to the name of Bitcoin, but in terms of market share, it's not there. So there's no point using people and saying it's Bitcoin. I think some people probably do some more harm than good trying to push that narrative, and I'm guilty of it if I have some drinks. Bitcoin is just a digital store of value. I would say that's bollocks because in the name of the paper, it is a peer-to-peer electronic cash system. It was never just meant to be a store of value. And in fact, again, the only reason why Bitcoins are worth so much money today is because people have been using it for commerce, right? Whether you're the guy who spent 10,000 Bitcoins on pizza or you're a guy who spent 20 on marijuana, right? So the next one is just use Litecoin for payments, and I don't want to. I want to use Bitcoin, so that's why I like Bitcoin Cash. I don't understand why that is now the narrative being pushed around. And in fact, I would say our Litecoin actually has a lot of issues with it. They've decreased the block time. That gets into the whole thing. So this one right here, most people can't afford to run a full node. That's a very interesting question that I'm going to address very much in depth later on. And the idea that on the BTC side is that everyone must be able to run a fully validated node at home, so that if the miners change something on you, you know immediately. There's a lot of problems with that line of thinking, and in fact, you're not a full node unless you mine, and that's actually right back in the white paper, which we'll talk about. And the last one, Dogecoin has more transactions. That might be true. I don't know, but I would say two things. Number one, Bitcoin Cash today is about where Bitcoin was in 2013, 2014 in terms of usage. And I really think the lack of development on using Bitcoin as a currency has pretty much put us right where we're supposed to be. Because I don't think most of Bitcoin BTC transactions are done with exchanges. They're not actually done in commerce. In fact, BTC has seen negative merchant adoption in the past 2 years. So I think every major place that was taking it has stopped taking it for multiple reasons. So what is the block size cap? So when Bitcoin was introduced in 2009, it actually didn't have a block size cap. It was introduced in 2010 because Hal Finney suggested it under the justification that if someone really wanted to with enough money, they could buy a ton of Bitcoins and spend them, a ton of them at one time, and just bog down the network. And if you were someone who had heard about Bitcoin on, the cypherpunk mailing list or something, you joined, you're like, this thing doesn't work, and you just forget about it. So his concern was that while it was young, it would just bog down, someone could bog down the network so much that people would stop using it and they wouldn't care about it, right? So basically, the block size cap is a way to say each block itself can only fit X amount of transactions. In the case of BTC today, that's 1 megabyte of blocks, which corresponds to about 3 transactions per second. Bitcoin Cash today is at 8 megabytes, which just multiply that by 8. And Bitcoin Cash next month will actually upgrade to 32 megabytes. So Visa itself actually does 24,000 transactions per second. So if Bitcoin ever wants to compete with Visa, has a long way to go. That actually corresponds directly with 8 gigabyte blocks, but obviously you're talking about Visa, MasterCard, whatever else. So it needs to be bigger than that no matter what. It would have to scale, and I'm going to talk about terabyte blocks today. And that's really the big difference, is that the Bitcoin Cash community is so far removed from this scaling debate. And I'll tell you why I think we can do that. Yeah. So the history in general, I had 2 slides here. One of them will kind of be a more timeline, so if this isn't, you don't want to look at this, you can kind of see it in timeline. But in 2009, Bitcoin was introduced with the white paper. Like I said, there was no block size limit in the initial code repository. It was then introduced by the suggestion of Hal Finney, and Satoshi and Ray Dillinger implemented it. Satoshi specifically said in 2010 on a forum post an exact way to remove it, and we'll get to that in a minute. 2010 and 2013, there was a ton of debate as to increasing the block size. People were kind of starting to look ahead, and they said, well, if Bitcoin becomes this large, then we're going to need to remove that 1 megabyte limit, which was always put in temporarily, if you trust in the original roadmap laid out for Bitcoin. That really goes on from about 2010 to 2015, where Bitcoin XT is launched by Gavin Andreessen and Mike Hearn, really the two big supporters of it. Gavin Andreessen was the person who Satoshi essentially handed keys over to when he left. Bitcoin XT has actually a very interesting history, and in the context of, today, I don't think anyone on the BTC side of things is going to say we're never going to increase the block size. It's more of we need to do it carefully and whatever else, right? In the case of Bitcoin XT, it's actually very interesting what happened. So Bitcoin XT became its own client that was competing with the Bitcoin Core client, which is really the main client BTC runs on. It's run by like 99% of the nodes, I think. So they start trying to convince miners to switch to Bitcoin XT. What actually ends up happening is nodes are DDoSed to the point where they're non-functional. In one case, an entire data center actually was DDoSed so badly until the one Bitcoin XT node was taken out, okay? In one case, an entire rural internet service provider was taken down because someone was running a Bitcoin XT node. There's a very large coordinated attack against anyone trying to run Bitcoin XT. Mike Hearn actually just did a Reddit AMA very recently, and he said one of the biggest things that he found was that miners were very hesitant to switch to Bitcoin XT because I don't want to necessarily misword this, but really, on a grand scheme, they just weren't ready to switch to a new authority figure. They very much in line with, okay, well, Bitcoin Core says this, therefore we don't really want to switch. And I think a lot of them also saw this happen. And when you're a miner, every second you're not mining, you're losing money. So you really don't want to risk having your miners taken down even just for a day, right? So in 2017, the blocks become full. They've been full for a little bit, and it's a contingency plan against the SegWit 2x agreement, which was an agreement made in New York, where the idea was, okay, the thing the core developers really wanted was to activate SegWit. We will activate SegWit if in exchange, 3 months later, we hard fork and increase the block size to 2 megabytes, okay? Now, a lot of the core developers were upset about that agreement because some of them were involved. That's kind of the whole thing. But really the main thing is that someone on August 1st says, by August 1st, Bitcoin ABC had kind of spearheaded the movement and said, we're just going to fork away and increase the block size. We're kind of done with this. And Bitcoin Cash was launched with an 8 megabyte block size with the support of Bitcoin Unlimited, Bitcoin Classic at the time, and Bitcoin ABC were really the three main different clients developing Bitcoin Cash. On the same day, or maybe that same week, SegWit is activated on the BTC network, and 3 months later, the 2x part is called off for lack of consensus. So actually, still to this day, Bitcoin now has SegWit, but they don't have an increased block size. And SegWit actually changed the block size to something called block weight, which can fit more than just the 3 transactions per second. But it's still not as much as an 8 megabyte block limit. So if you want to see this kind of in a timeline, I also stole this, but just a nice, easy way to kind of envision it. I don't think I missed anything else. Yeah.
How did XT different?
So
How did it differ from the base client?
the core client, it really was just a client that increased the block size. There were a few other things different. They were a big component like BIP70, which is the BitPay merchant stuff, but really on the grand scheme of things, it was just Bitcoin Core with increased block size. I actually don't know the exact size that they were trying to push for at that time, but I know Gavin was a big component of flipping to 32 even back in 2013. So, and I have some quotes that'll kind of get that through. So number one, Satoshi, October 4th, 2010, describes exactly how to,
Can you explain how implementing the block size would prevent a big user or a big buyer from bogging down the network?
Sure, yeah. So that's actually kind of interesting because even in the case of Bitcoin Cash, with 8 megabyte blocks, we had a day, it was probably less than a day, where the blocks were actually full, 8 megabytes, and someone was clearly either running a script or something and just sending money through, or just filling blocks up 8 megabytes at a time. So actually, let me see if, I'm trying to remember where I start talking about that. Well, we'll just talk about it now, actually. So if you actually look at, in the case of Bitcoin, the How Finney attack, where he said someone can just flood the network with transactions, right? There's two things wrong with that line of thinking. Number one, it was right for its time. When Bitcoins were worth less than a penny, or even less than $1, someone with $10,000 had enough where they could really cause issues for the network, and the network was young. So the same kind of thing, if you're a new user trying to try out the network, and that is a bad experience. Now, in the case of Bitcoin Cash, someone was spending money to fill up 8 megabyte blocks. That cost them $30,000 a day to do that. So in the case of the Finney attack, that's what they call it, the Finney attack. It's not economically viable, even with 8 megabyte blocks. It's not going to be economically viable with 32 megabyte blocks, and when I hope to see the block size completely removed, it's not going to be viable at all, because all you're doing is wasting money. You're just spending money to pay miners. And if miners are actually equipped to handle very large blocks, I mean, how much time does anyone go and just randomly spend money to bog down Visa's network? I mean, it just doesn't happen. And I really believe that that's more of an economical attack. I think Hal Finney was justified in his concern at the time. I think that's why Satoshi and Ray listened to him. But I would say once Bitcoins became worth more than $100 even, it's really not necessarily an economically viable attack. And I mine, that's great. If blocks are full, I'm making more money. I mean, so miners don't care if you're bogging down the network. And in fact, that's really one of the big things that I'll talk about is Bitcoin Core really started calling a lot of these transactions spam. They said, the gambling services were spam because all it was pennies moving around at a time or whatever else. I would argue if you're willing to pay a fee with your transaction, it's absolutely not spam. You have every right to make that transaction. So October 4th, we'll finish up the block size issue here. October 4th, 2010, Satoshi specifically starts talking about, okay, well, here's how we can remove it. Jeff Garzik makes a thread, and Satoshi says it can be phased in like this, and he just writes some pseudocode that says if the block number is greater than this, max block size equals larger limit. He says specifically you can start being in versions way ahead, so the time it reaches that block number and goes into effect, the older version is already obsolete. And what he's really talking about there is a hard fork. When we're near the cutoff block number, we can put an alert into old versions and make sure they know they have to upgrade. On the BTC side of things, you actually have quite a different perspective. So Luke Dashir is one of the core developers, actually wants to decrease the block size on Bitcoin Core. So he is very much, this kind of gets into the issue of, well, you need to be able to run a full node. So if you live in a third world country, you don't have enough room for 1 megabyte blocks and to hold the blockchain, all that kind of stuff, right? That's fine. I'll address that argument shortly here. But I also want to point out, Adam Back, the CEO of Blockstream, has kind of been holding a carrot about the block size forever now. So in 2015, he posts agreeing with Jeff Garzik saying, yes, 2 megabytes now, 4 megabytes in 2 years, and 8 megabytes in 4 years. Which means he really was talking about, in 2015, having an 8 meg block size next year, right? And there's been absolutely no movement on that whatsoever. Which really makes you wonder why. And in fact, I actually meant to put this image in here, I really should have. In the case of Bitcoin, if you look at the actual market cap of all altcoins, as soon as the blocks became full on Bitcoin, and reliably day in, day out, 1 megabyte blocks are full, the altcoin market spikes. And it's because people want to make cryptocurrency transactions, and the block size really took a lot of value away from Bitcoin. I've mentioned this a little later. In the case of Ethereum, Vitalik actually wanted to build Ethereum on top of Bitcoin. He didn't do it because he understood that the types of transactions he wanted to make were what were considered spam, essentially. And we'll talk about that a little bit here. But I do want to mention some of the arguments against block size increase. Number one, the network can be flooded with spam, kind of what we were talking about, the Hal Finney attack. Again, it's just not really an economically viable attack vector. And all someone is really doing is paying miners money. In the case of miner centralization, this is one of the biggest arguments that I think is a valid debate to have. I don't think this is something that you can really laugh at, but I will address this. The issue is that they say, well, running a full node becomes burdensome if you have to have terabytes of, multiple terabyte hard drives to store the blockchain or whatever else, right? And so now users are now able to validate if the miners change the consensus rules on them, and that's a problem, right? That's fine. And then the last one is actually something Gregory Maxwell says, a core developer, that a fee market is actually good for Bitcoin because it forces users to conserve block space. That is absurd to me, and I'll show you why. So in the case of fees, in December, I took the average transaction fees. Really, the median transaction fees are probably a more accurate thing to take. I took average for both BCH and BTC. But in December 2017, the average fee to make a transaction was $50, okay? $50 to get your transaction into the next block. You could pay with a slower fee. It then might take, at one point, I know it took someone months to try and pay the 1 Satoshi per byte fee on the BTC chain. And for the first time, the reward for miners in transaction fees actually surpassed the mining block reward. Gregory Maxwell declared this a success of Bitcoin, and that this is exactly what we wanted. And he sends a mailing list out, and he said he was popping champagne, right? Today, the BTC fees average at about $1.20. The number of daily transactions are at a low since March of 2016. So really in the case of people actually using it in commerce, hasn't grown at all. In some cases, people are okay with that. They think that it doesn't need to be used for commerce, that's fine. On Bitcoin Cash, the average transaction fee is 3 cents. Really, every wallet that I made for you guys, I paid a tenth of a penny to send 50 cents onto the wallet. And that'll always be true as long as there's room for our transaction in the next block, okay? Something I wanted to mention though, in the case of fees, so even if you have $1.20 as your average fee, Bitcoin is supposed to be for everyone in the entire globe. So if you live in Africa, okay, you can't afford to make a $1.20 transaction fee. In fact, you can barely afford to make a 3-cent transaction fee. Transaction fees have to be minuscule for Bitcoin to work and actually provide this economic freedom that I find very important, the reason why I got involved in Bitcoin to begin with. In the case of Bitcoin Cash, that's going to be true. And as we scale to infinity, whatever you want to call it, you can kind of think of, well, how is a miner going to make money if the block reward goes down and all that kind of stuff? Well, Coca-Cola makes less than a penny in every can that they sell. But Coca-Cola pushes millions of cans through every day, right? And so they actually make a profit on that. And that's kind of the goal that I see for Bitcoin, is you're either going to see everyone using it daily, or no one's going to use it at all. Because if I'm a miner, I have no incentive to actually mine Bitcoin when the block reward goes down, and if no one's using it, I'm not making that much in fees, so I'm going to turn off my computer. So, the argument of, well, you have to run a full node at home is completely absurd, because that looks terrible. But this is step 5, or section 5 of the white paper. The steps to run the network are as follows. Step number 3 is each node works on finding a difficult proof of work for its block. So Satoshi himself, when he made Bitcoin, said you are not a node in the network unless you mine, okay? So actually you running a fully validating Bitcoin node at home does absolutely nothing. And it does nothing to a point where, I'll show you very shortly here, you're actually so far behind the other miners that you're not actually validating anything. You're just getting told something after it's already happened. So if your whole purpose of running a fully validated node is that, well, the miners can change something, I want to be able to change something myself, you can't. You can't actually do anything. You are just lag behind the network anyway. You're an observer to what's happening. And I'll mention one other case too. Everyone goes, well, the blockchain is so big, I need to be able to run a node. That's fine, actually. I have nothing against people running full nodes at home, or validated nodes, or whatever. But let me ask you a question. If your argument is, well, we can't increase the block size because I don't want 10 terabytes of hard drive space at home, why don't you take a hash of every single block that comes in? So a block comes in, you validate the transactions in the block, hash the block, and now you can just keep a ledger of hashes And now you'll know if any hash changes for any of the blocks. And then you essentially have a simple way of saying, well, the blockchain is valid, right? And then all you're really taking in each time is the block itself. And we're going to talk about that because that's very important. As Bitcoin scales to infinity, you're going to need nodes that aren't mining doing things. And this is going to become important. I took 2 quotes just to show you that the idea that you're supposed to run a full node is absolute bollocks as well, because Satoshi himself in 2008 said only people trying to create new coins would run network nodes. At first, most users would run network nodes, but as the network grows beyond a certain point, it would be left more and more to specialists with server farms of specialized hardware. The server farm would only need to have one node in the network, and the rest of the LAN connects to that one node. If the network were to get that big, and I put this part in because I think it's important, if the network were to get that big, it would take several years, and by then, sending 2 HD movies over the internet would not seem like a big deal. Which is exactly where we are today, right? I download movies all the time. It takes minutes, right? And that's going to get better as we scale, with Moore's law, right? Hard drive space will get better, bandwidth will get better. So to block innovation on the basis of, well, we can't do this today, is absurd. And the second quote I took from 2010 really gets to the root of the issue. It says the current system every user is a network node is not the intended configuration for large scale. That would be like every Usenet user runs their own NNTP server. The design supports letting users just be users. The more burden it is to run a node, the fewer nodes there will be. These 2 nodes will be big server farms. The rest will be client nodes that only do transactions and don't generate, as in mine. So this really gets into the root of the issue as to why Bitcoin is innovative and why it can scale and why scaling the network itself creates a network capable of doing things we never thought were possible. So Bitcoin itself is something called a small world network. It's actually not a mesh network like we're used to in the case of things like BitTorrent and things like that when you use the internet. And I put just a definition from Wikipedia for both what a small world network is and what a mesh network is. And this is very, very, very important to understand why Bitcoin works, why it can scale, and why the intended configuration at scale is large miners competing with each other. In a small world network, the neighbors of any given node are very close by. So you're not actually, in the case of a mesh network, right? If I want to send, money from here to the back of the room, I'm going from node to node to node to node to node to node to finally get back to the back of the room, okay? In the case of Bitcoin, that's actually not how it works. Miners themselves are heavily incentivized to connect to every other miner in the network. So if I'm a miner and I'm finding blocks, for example, I want to make sure that if I find that block, I'm going to propagate it as fast as possible to everyone else in the network because I want to make sure I get the block reward. If someone else on the other end of the globe finds the block at the exact same time as me, but has a faster connection, maybe I wait a second before I send out the block. Every single second, I'm not interconnected, highly connected, and communicating with the other mining nodes in the network, I'm losing money. So in the case of economic incentives, Bitcoin solves this by heavily incentivizing miners to be as connected as possible with each other. In Bitcoin itself, the distance between nodes is about 1.32 plus or minus 0.07. And what that really means is, if you're right up here, I can reach a node that can communicate with the entire network in under 2 hops in the network. And that's really, really cool. And I'll show you some images here in a second to explain why it's important. In the case of a mesh network, really, like I said, you're working from node to node to node to find the most direct path from one node on one end of the network to a node on the other end of the network. In the case of the Lightning Network, that's really what the Lightning Network is all about. It's overlaying a mesh network on top of Bitcoin and allowing you to transact in a mesh network. And I believe that's a step backwards. We've actually created something, well, I haven't done anything, but Satoshi created a network that is really, 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 really powerful. And again, I'll show you that in a second here. To me, scaling with something like the Lightning Network actually is a step backwards with regard to what it means to build this network that is highly connected. One paper here that some Microsoft researchers wrote, it's called On Bitcoin and Red Balloons. If you're interested in this, they essentially determined that any network with more than 3 hops in it can be Sybil attacked. And what a Sybil is essentially spoofing the identity on the network. Lightning Network itself, well, today you can get somewhere in a hop, maybe 2 hops. if Lightning Network is going to scale for global payments, which is what I'm told the whole point is, right? Then you're going to have a network that has at least 8 to 10 hops to get from one place to another. And on a more granular, on more dangerous scale, in my opinion, you now have you already see this today in the mainnet, a hub and spoke model of transactions. So I have a graph here in a second, but the idea is that on Bitcoin, if you take out one mining node, there are still other mining nodes competing, and the system doesn't get bogged down. Maybe the difficulty will adjust eventually, and so it might slow down for a little bit. In the case of a mesh network, if one of the biggest hubs in the mesh network goes down, I may not be able to actually connect with a node that I used to be able to connect to. To me, that kind of brings us back to a trusted third party. And so I have some cool images here to really kind of get this point across. So what this is right here, so this is going to be what's called a Bitcoin giant node forming. So these are all miners, and this is showing what actually happens when miners are they're incentivized, again, to connect to every other mining node in the network. This is actually what ends up looking like here. So basically what's happening here is miners are trying to connect to as many different nodes as possible, and I really mean mining nodes. Eventually you end up with is a very densely connected network. And that means that if I propagate a transaction to this node right here, they're very connected to the rest of the network, where I'm pretty darn sure my transaction will be seen by every other node in the network. In the case of Bitcoin, your transaction actually reaches every mining node in the network in 2 to 3 seconds. And the cool thing is that as you scale the network larger, that gets smaller and smaller. So you can actually reach a point where in maybe less than a second, every single node in the network has your transaction. That's really important when it comes down to how are we going to handle things like zero confirmation payments, right? So if blocks only come every 10 minutes in Bitcoin, I'm not going to go to the coffee shop, spend Bitcoin, and then wait 10 minutes to walk out the door, right? You can really create a system here where merchants can be pretty darn sure you haven't double spent your transaction, and they're going to take, just like they do with credit cards today, an acceptable amount of risk in taking your payment. And a network like this actually lends itself to doing that. And we have a really cool one. This is my favorite one here, but so what this is here is blocks being propagated throughout the network. Okay, so what you're seeing here is, okay, a block was found. I'm going to start communicating out to the mining nodes that I know about. All of these nodes out here are the Raspberry Pi nodes that we're told are so important to the network. They're the very last things to ever hear about a block. They're the very last things to ever be talked to, because there's no incentive for a miner to heavily connect itself to your Raspberry Pi node. They don't care about it. And look, you can still see them out here. Some of them still haven't even gotten yet, right? This is the problem with the idea that running a node at home actually matters, because you're not actually doing anything. And in some cases, you haven't heard, if everything here changed on you, you may not even know about it until it's already changed and it's too late. So what Bitcoin actually creates is an economic model where miners are incentivized to act honestly, so that you have a pretty good degree of certainty that the network works. And Satoshi himself actually talked about this. Well, real quick, I guess I'll show this here. Getting a little ahead of myself. This is the network topology of something like Lightning, a mesh network. So you can see here, and it's going a little slow, but it also is slower than something like Bitcoin, because you have to work your way through other nodes to get across the network. And I'll show you this. You kind of get the point here, but this is my favorite one, I think. This really explains how Bitcoin works, okay? This is how Bitcoin is going to work at scale, Bitcoin Cash itself. So right now here you have mining nodes, and then in between you have user nodes. Okay, so user nodes are people like you and me with our cell phones, or maybe even just someone running a fully validated node at home, or maybe even a merchant, right? If I'm a merchant, I might run a node on my computer so I can propagate transactions. So here what you have is you have miner nodes densely interconnected in the network, okay? So now user nodes are here. So let's say a user node connects to a mining node in the network, all right? If I'm a merchant, and I'm this merchant right here, I'm going to propagate my transaction to maybe 1 or 3 miners. almost instantaneously, miners send it across the network. And now, within 2 to 3 seconds, every single miner has your transaction, okay? D is less than 3, specifically it's less than 2 in the Bitcoin network today. And like I said, that gets lower and lower the more you scale, and the more incentive there is for miners to actually become these super powerful, highly connected, high bandwidth nodes, okay? So let's just take the case of I'm a merchant, all right? And this is, I think, just very important to talk about. This is why Bitcoin works, why it'll work at scale. If I'm a merchant, so if I'm a merchant here, when you go to the store, okay, and you swipe your credit card, do you care if the merchant actually takes your money or not?
No.
Probably not, right? Who cares? The merchant cares, right? So in the case of a lot of these things that we're talking about, told to worry about in Bitcoin, things like that, Bitcoin itself is just an economic system. That's all it is. If I'm the merchant here, and you come into my store and you pay me money, I have the incentive to propagate that transaction as rapidly as possible to every mining node I possibly can. And maybe maybe there is an incentive for me. I validate so many transactions daily that I'm going to run this full node. Maybe I'm going to become a miner itself. I don't know. If I'm like Walmart or Amazon, right? But I don't have to be. I can just make myself very highly connected in the network and immediately propagate my transaction out. So let's say you come into the store. This is how something like double spends will work. It's zero confirmation. Everyone loves to now crap on the Bitcoin Cash people saying, oh, well, they think you can just spend everything without confirmations. You can. You actually can, and you can do it in a variety of ways, okay? So number one, if I walk into the store and let's say I pay with Bitcoin, right, and I buy the coffee. And the concern is, well, you might go double spend that money, therefore the merchant can't really take that transaction until it's confirmed in the next block. If within 2 to 3 seconds, your transaction is seen across every single node of the network, the merchant can do that scanning in that 2 to 3 seconds, okay? And they can see if the address you just spent from double spent the money you're spending. So think about that, okay? So everyone goes, well, zero confirmation doesn't work because it's not in the blockchain. I'm not saying it works permanently. I'm saying become a merchant. If you're a merchant, when you go to the store and you swipe your credit card, you put the credit card in the chip, how long do you wait? You wait about 10 seconds until it beeps for you, right? And then you pull the credit card out. We're talking about a system where merchants are heavily incentivized to scan the blockchain, running a node like Bitcoin. Bitcoin XT does this today. You can just validate that the address hasn't double spent, okay? And if it has double spent, you deny the transaction. If they attempted any kind of double spend, you deny the transaction. In the case of miners themselves, and this, again, this is another contentious issue, but I'll just very briefly talk about this. I think we should talk about this later if you aren't interested in this. If you're a miner, is it good for you, let's say you support Bitcoin Cash, is it good for you if a double spend transaction is included in a block? Probably not, right? Why? Because you as a miner are incentivized to grow Bitcoin Cash. You make the most money if Bitcoin Cash grows in value, right? If Bitcoin Cash becomes a network where people are double spending transactions, it's not a valuable network, right? So, don't get me wrong. Has there been successful double spends? Yes, there have been, okay? But you now have in the Bitcoin Cash community, 60% of miners have agreed that if they see a block with a double spend, they're gonna orphan the block, okay? And that's what Bitcoin is all about. Miners having the freedom to make decisions on their own. No one is supposed to be forcing miners to do this. We're not going to write any code that tells miners, hey, don't do this, whatever else. Miners are economically incentivized not to build a system full of double spends. And you now have over half the miners pledging not to include double spend transactions in the block. Why is that important? Because if you're a miner and you're like, well, I don't care about that pledge, and you find a block, good luck, right? It might get orphaned, you just wasted all your time, wasted all your money. So it really becomes an economic game. I kind of veered off course here a little bit, but I just think that this is really important to understand. Are user nodes important? Of course they are, right? I mean, it's cool that you can run a node at home, whatever else. But really, the miners are the only ones that do it.
And so far, this is true for both Bitcoin and Bitcoin Cash, right?
Sorry.
So far, this is true for both BTC and BCC.
Yep, exactly. Yep, this is exactly how both networks operate. Yep. So this is kind of interesting, and I just want to touch on this briefly. It's a big issue in the Bitcoin Cash world today. In 2013, Emin Gunsirer and some other guy from Cornell released a paper, okay? And it talked about something called selfish mining. And the selfish mining attack is the general idea where a miner will withhold blocks. So if they find a block, they'll withhold broadcasting that to the network. And the idea is that they could essentially create a system where overall revenue for all miners decreases, and they can selectively publish blocks in a way where they can create their own chain and draw miners over. And so instead of the regular 51% attack you read about, maybe 25% miner can perform this attack, siphon off hash rate to then eventually gain 51% and attack the network, right? This is really important because that paper has been used to justify a whole host of things. But to me, the biggest problem with that paper is this is what they conclude, and they put this in the second paragraph. Bitcoin is not incentives compatible. So their paper concluded that Bitcoin does not work as an economic incentive system. There's a whole debate about it, whether it's a correct paper or whatever else. We'll find out very shortly. Someone has run a simulation that actually, well, I'm not going to get into it, it's a whole thing. But this is a very important concept between the Bitcoin Cash communities, is Bitcoin broken? Does it need to be fixed? Or are the economics of the system itself good enough that the network works on its own and it punishes bad behavior? And actually, Satoshi himself talked about this. So I'll skip ahead real quick. So the second point here, if the majority of CPU power is controlled by honest nodes, the honest chain will grow the fastest and outpace any competing chains. Satoshi talked about this a lot. He said that the system works in a way where honest miners make the most money. So if I'm a miner and I'm greedy, which all human beings are, you're going to do the honest thing. You're not actually going to do something like selfish mining. In the case of selfish mining, I'll mention this very briefly, it would cost you $3 million. So the hypothetical attack vector is if you have 33% of the network, you can do something in a way where you get 41% of the blocks. Okay, so you get more than your fair share of blocks. You as a miner can actually spend $3 million less to just buy that hash rate and get 41% than actually perform the selfish mining attack. You actually lose, and the opportunity cost of things, you can just buy, you spend all the money you took, losing money and whatever else doing selfish mining, and you can buy 41% hash rate. And that would be the honest way of doing it. So even in the case of being malicious, the honest way works. Step back real quick. So Bitcoin is entirely an economic system. It's modeled after a Stapleberg competition. I put just another definition for Wikipedia there. But really the idea here is that it's a game of economics in which the leader firm moves first, and then the followers move sequentially. In game theory terms, the players of this game are a leader and a follower, and they compete on quantity. In the game of Bitcoin, quantity is hash rate, okay? And really, miners are just constantly in this state of competition. Every single second matters to their bottom line, and that's why you can trust in the one thing, and I put on the next page here, trust in the fact that humans are greedy, trust in the fact that miners spending millions and millions and millions and millions of dollars on computing equipment want the network to succeed. They want their investment to return money for them, okay? I like this quote because it's 100% true. A chain of digital signatures was first written about in 2001. That's not why Bitcoin is innovative. And in fact, if you talk to people now, everyone goes, well, blockchain was essentially created by Bitcoin, and that's whatever. Bitcoin is actually innovative because it's an economic system to ensure security of the network. It's innovative because it creates this entirely new network that incentivizes people to be highly connected, and it allows transactions to move across the globe very quickly. On the whole, they're incentivized to act honestly, and I say that everyone goes, well, Bitcoin's trustless, and I say, well, actually, you trust in human greed, which is pretty ubiquitous. Economic incentives to scale, I put this in here, I'll kind of breeze through it here, but basically, we talked about a little bit of this. adding full non-mining nodes to the network doesn't do anything. Like I said, really you're not doing anything. You get to like pat yourself in the back that you're validating like that the blockchain exists wherever else. But you really don't do anything. In fact, Satoshi in the white paper specifically talks about this. He says you can run an SPV wallet. Does the exact same thing. My phone has an SPV wallet. You can, ping the network and find stuff if you want it, but there's really not any incentive or really no reason for you to run a network. And in fact, you actually create a system where you slow down the network, so which is fine. It's not a big deal. Like the D will always be less than 2, so it's not a huge deal. But you actually do kind of open up the network to possibly have civil nodes on the network, which again doesn't matter though because miners are all that matters. Something I thought was interesting. So actually, Joannis Vermeerwald recently did a presentation talking about, okay, well, if we were to do terabyte blocks today, 1 terabyte blocks today, what would that look like? He actually written a blog post about this, I think 2 years ago, maybe, and he concluded that it would cost you $20 million to run a node that could validate 1 terabyte blocks, right? 2 years later, he kind of reevaluated the numbers, whatever else, and it's actually down to 1 million. So today, and this is kind of Satoshi's whole argument when we talk about Moore's Law, things like that, in 2 years, we've actually decreased 20-fold as the cost it would take to run a terabyte validating block. Now that's a lot of money, right? So now can you at home go run a node that validates terabyte blocks? Of course not. And I think this is really the big divide. I align with what Satoshi always envisioned, which was that companies and large server farms would be the ones mining. It's not going to be users, and this is why you have all these altcoins now that really think user nodes matter, democracy, things like that. I'm not in that camp at all. I think it's perfectly reasonable that if we're going to create a system where anybody in the globe can transact instantaneously, basically for free, I'm actually okay with companies, scaling and competing with each other. You create a system where companies are just competing with each other across the globe, and then even if you just end up with 3 companies competing, 3 mining pools, whatever else, it's actually very decentralized, believe it or not, because it's decentralized in a manner that, yes, maybe they're the only ones making mining profits, but this gets in the whole thing, but you can become a validating node on the network, okay? So you can lock yourself in a smart contract with miners. When billions of transactions are being made daily, you can actually make money validating transactions for the miners. So we're talking about an entire new economy that's going to emerge when Bitcoin scales, Bitcoin Cash scales to the globe. And one other thing I want to mention is airplanes cost a lot of money. And I know this isn't a perfect analogy here, but flying across the country, flying across the globe is actually relatively cheap today. And that's kind of the way I envision the way Bitcoin mining will work, is that you're going to have companies that obviously do spend a lot of money on nodes, but the benefits of what that provides the globe is actually way bigger than any kind of like centralization concerns that you might have. I think that's a perfect analogy of what I can find anywhere now today. But yes, the actual hardware of like buying your own plane and whatever else is expensive, but yeah. So I'm pretty close to the end here. I did want to mention a couple things. I didn't want to get to this mainly because I'm not smart enough to really tell you all about it, but this is very recent in the Bitcoin Cash world. Bitcoin itself has actually turned complete. Craig Wright first talked about this in 2018 publicly. This was just recently confirmed by Ryan Clemens, who is the CTO of yours.org. And I've been reading a lot about it. It's very, very interesting. Basically, Bitcoin script itself is not Turing complete, but it acts as a 2-stack pushdown automata, which is very similar to Forth, if anyone knows the programming language Forth. And the blockchain itself actually acts as a Turing tape. Very interesting, and really the point I want to get across here is that, number one, this means that things like smart contracts, tokenization, all these other kind of things are possible inside of Bitcoin without actual second layer itself. It just requires us to think differently. And something I found really interesting actually is that if you actually go play with Bitcoin script, every IDE on the internet is like gone. Like 2013, people just stopped caring about Bitcoin script. People stopped thinking about, well, what is possible here? And part of that is twofold. Number one, a lot of the opcodes were removed from Bitcoin. So you can't do a lot of basic arithmetic and logical functions. But that's all coming back into Bitcoin Cash. We talked about zero confirmation payments. One thing I did want to mention here, if you're really interested in kind of that yo, how's this payment system gonna work, zero confirmation, all that kind of stuff. I really recommend reading Satoshi and Mike Hearn's emails, which I don't think a lot of people actually know exists. They actually came out late 2017. Mike Hearn was a Google employee that worked on Bitcoin J and really did a ton for Bitcoin. But Mike Hearn actually, this is like 2010, is asking a lot of the questions that we're still debating to this day. And Satoshi was very, very clear as to what he envisioned for the network. And that's fine if like people don't want to go along with that, you know? But I think it's important to look at the guy who created this network and try to understand what he wanted to do with it. And everything he says in those emails is all Bitcoin Cash is today. And it's pretty far removed from what the roadmap is on the BTC chain. So what's next for Bitcoin Cash? On May 14th, there's another hard fork. So Bitcoin Cash is committed to hard forking every 6 months. Kind of does, in some ways, maybe a too reactionary measure to not hard forking in the past like 8 years. But this is really cool. We're gonna have 32 megabyte blocks, which is pretty much the furthest the protocol can go today without causing some other issues. But they're working on that too. Re-enabled opcodes. I put this in there. I meant to actually put a link, and I'll send it out. You guys want any information, just email me or whatever. But there's actually a great post on yours.org someone made that talks about all the use cases for a lot of these re-enabled opcodes that are coming back into Bitcoin Cash. And it's just really cool. You can take a look at that. Increased fungibility. One thing I did want to mention with respect to fungibility, Monero is kind of like the big, king of fungibility today. I'm not claiming like we're going to get there anytime soon in Bitcoin Cash, but in the case of small block size and big block size, you also have to understand with regard to fungibility, if it costs you a lot of money to move coins from wallet to wallet, you actually create a system where it's not fungible whatsoever, because if it's expensive to move money from one wallet to another, mixers become unviable. In fact, there's not really that many mixers alive today on BTC anymore. And so really, if you want mixers to be a thing, if you want money to be able to move with a high velocity, you need low fees. And that's why I don't really correspond with this just digital store value line of thinking. Like I said, smart contracts, tokenization. If you're interested, you can make 3.5 million euros. CoinGeek is sponsoring the whole tokenization contest, so if you think you might know how to create tokens. And actually, something I just read, so Jonas Vermeerl, the guy who just talked about the terabyte blocks, his company Wocat has actually just introduced a very interesting proposal to do tokenization without any added anything. Go ahead and send that to you if you're curious about that too. I put some projects on here. These are some really cool projects happening on Bitcoin Cash today. JoyStream is really cool. It's a torrenting client that actually lets you get paid in Bitcoin Cash to seed torrents. So if you ever want to find that torrent of a movie from the 80s and you can't find it, this actually provides an incentive for people to keep seeding those torrents, right? I've actually used this quite a bit. It's really cool just to see your wallet, everything on chain, your wallet increasing by pennies at a time just for seeding. Yours.org is a really cool project that kind of acts like a Reddit type system. They have a little ways to go to get there, but everything is on chain as well, so you can post articles, charge people to see the rest of your article, or not do that, and just people voting. It creates the kind of an economy of content. So if you vote on something that becomes very popular, you actually make money because you're kind of credited for being the curator of that content. Memo.pch or Memo.cash just came out. Also really cool, kind of, I think, aiming to be like a Twitter replacement. Everything on chain, changing your profile, makes a transaction, which again, I think is kind of interesting. I'll make this very brief, but even in the Bitcoin Cash community, you have a lot of people we shouldn't be doing this. We shouldn't be making transactions to change your profile name on a social media. You know what I mean? And I will still completely disagree with that, because if you're paying money to do that, you're allowed to do whatever the heck you want. And that's really, I think, the big philosophical difference between the BTC and the BCH side. Bitbox is kind of just an open source platform to help you build applications. Tipper, you might have seen that on Reddit or Twitter. You can just tip people money. It's a third-party service, so you're kind of still trusting Tipper, but it's been pretty cool. And then I mentioned EPCH. These are some guys in Venezuela that are taking donations in Bitcoin Cash and handing out food to local communities, which I think is just really cool. And you can pay them 5 cents, and that actually helps them quite a bit. Yeah, and then adoption is kind of through the roof with respect to like what's happening and like how fast it was doing. I won't say through the roof because transactions are still pretty low, but the third world community is really going to benefit from Bitcoin Cash. If they're allowed to make sub-penny transactions, then you can provide them a money that isn't inflated, things like that. I'm sure if you're here, you probably understand why Bitcoin is important from this perspective of, places like Zimbabwe inflating money at will and things like that. And then, BitPay now takes Bitcoin Cash, so that's kind of cool. Rocketer is a similar service. I just want to mention some of those cool projects, and then this is very brief here. Any resources you want to be curious about, you can email me. I did very recently start doing a podcast, so I kind of put that there with the BCH boys, not bitch boys, but but yeah, so you can check that out if you want. But this is kind of some of the resources that I find pretty helpful. Yeah. Any questions?
Sure. I have a question with a few sites back. The few times you talked about the merchant nodes there, that one there, a few times when you're talking about the difference between Bitcoin or Bitcoin Cash, you seem to be lumping together the quote unquote Raspberry Pi nodes or the non-mining quote unquote full nodes as bad and clumping them together. We don't need to care about those, and also they do nothing. But then you're also saying the quote unquote merchant nodes or the listening nodes or the validating nodes are good and they do something. But it sounds to me that from a technical perspective, they're both not mining, they're both keeping the full blockchain, they're both deciding what's in and what's out.
Right.
What's the difference of why is one group bad and one group
Yeah,
good?
no, that's a good question. I probably didn't get that message across. Running a Raspberry Pi node isn't bad. There's something bad about doing that, right? And in fact, I only put this civil part in just because I think it's important to at least note that those nodes are more vulnerable to some kind of civil attack, or to being civils themselves. But you're absolutely right. There's something bad about running a Raspberry Pi node. You just don't do anything. And in the case of, the reason why I talk about merchant listening nodes, which really are the exact same thing as Raspberry Pi node, is because I view the Raspberry Pi node camp of people, I guess, as I need to validate the blockchain, and that's it. You're not actually receiving transactions. Whereas there absolutely is an incentive to run a node that you can't mine. Like I'm not going to mine in a coffee shop, right? But there is an incentive for you to run a node that propagates the transactions very quickly. In the case of something like, could you run a Raspberry Pi node at home and still incentivize yourself? Well, I want to make these transactions very quickly, of course, right? And whatever else. But I guess in the case of, the big difference here is that if I'm a merchant, the reason why I'm running the node is to be connected to the miners very quickly and to propagate out. I guess I just don't understand, I understand it, but it doesn't seem to be an actual argument for why I need to run a Raspberry Pi node at home to validate the blockchain, I guess. You know what I mean?
I guess one of the arguments I've heard in favor of that would be the concept of a user-activated soft fork. The idea of, yes, they're not validating transactions, but they are validating blocks coming in. They may not be receiving blocks within seconds of them being mined, but even if they're receiving it a minute or two later, even if blocks are spaced 10 minutes apart, if you're receiving it a minute after it was mined, you can still contribute to the validating and choosing whether or not your node or that node propagates it to its peers. That's the concept of the user-activated soft fork was utilized of, hey, we're not going to propagate your blocks, we're going to orphan your blocks,
Right.
sort of a thing, and if there's enough of us, it matters.
Yeah. No, you're absolutely right. First of all, I think a user-activated soft fork is actually, Vitalik wrote a pretty interesting article about it where it kind of forces a hard fork in a way. The thing is that so let's say that happens, okay? Let's say the user-activated soft fork forks away from all miners. Who's going to continue the chain, right? So in some respects, yes, you're right that maybe now these nodes won't, but if you're not mining, then even if every single Raspberry Pi node, let's say, are all the UASF forks or nodes, and the miners don't care, then only one network is going to grow after that anyway, right? I mean, if you're not mining on this UASF side of nodes, right, then nothing's going to grow. Transactions are going to get added in the blockchain anyway. So I think you're right that in that scenario, maybe you would want to run the node to have your voting or whatever else, but all you really end up doing is voting yourself away from the network that grows. You know what I mean? Does that make sense or no?
I think
Or like, do you,
it makes sense. The argument against that one is if the ones who are running the user activated software flagging sort of nodes are the ones who are doing the transactions. Yes, miners can mine, they could mine empty blocks, but the idea that if the majority of the users who are actually going to be using whatever currency it is are the ones who are saying, we're going to orphan you if you mine differently, then it's the financial incentive of the transaction count will drop down, the actual transaction fees will drop down. There's a financial incentive for any miner to then pop up and say, well, there's no competition on the other side.
but who puts the transactions in the block?
That's the incentive for a miner to flip and start following the rules that the other group is saying. We will only, propagate a block if it follows these rules. If all the miners say we're not going to do it, then there's an incentive, financial incentive for someone to say, well, sure, I don't really care philosophically about it, but hey, if you're offering me money to do it this way, sure, I'll mind those.
Sure, yeah. But I think, again, I think that really is very similar to a hard fork in a way, right? I mean, you essentially fork away, but I think in general, you still need a miner to agree to do that. And that's really, I think, the main point. I actually disagree. I think in the case of SegWit, for example, I personally think it should have been a hard fork. I think that would have been more valuable, I guess. You're right. I think even today, SegWit is still at 30% usage, so I think a hard fork would have been more beneficial. But I understand both sides of the argument for sure. Yeah. But again, I still think you need the miner anyway. So in some ways, that may be important, but even if every one of those nodes left the network, the miners could still propagate their own network too, right? But yeah, thanks about it.
What does it take for a node that is not mining to be contributing effectively to the network? I mean, is that network latency, network bandwidth, storage or memory bandwidth, or what do you need to be good at to be actually validating fast enough? You
need to mine. Yeah. So I guess that's my argument here is that you really, so if you're not mining.
So it's just hash rate.
Because if you can't actually create a new block, you have no power in the network. And if you have no actual power to orphan blocks, for example, maybe in the case of UASF, right, you could on your own chain, but in fact, you're not actually growing a chain after that. You know what I mean? You may be saying, well, I'm not going to accept this on the chain I already have, but you're not actually growing a chain anyway. So in order for a new transaction to be made, you need a miner. A miner has to say yes to do it. And so as far as being part of the network, I would say it comes back to this, where each node of the network is really defining the next block.
And what would the merchant node do then? The non-mining ones, how would they? What do they need to be?
Sure. So in that scenario, I guess what I would say is you could do it with any kind of connection. In the case of Coinbase, right? Coinbase doesn't mine, but they're very heavily incentivized to be connected to miners, very, very, very well connected with them, because they want to make sure that people aren't, messing with them or whatever else. So they want to really be interconnected. I don't think. I see what you're saying, right? They have higher bandwidth, things like that. I would argue it's not really necessary, because if your whole point as a merchant is to be is someone coming into my shop and double spending coins, you can do that in 2 to 3 seconds regardless of your bandwidth, for example. So in that scenario, I would say you really don't need that much. You just need a Raspberry Pi, probably, right? In some respects. And I guess I should clarify. I'm not saying I have no problem with people running nodes. And running a node at home is really cool. You can do a lot of cool things with the blockchain and whatever else. I guess just what I would push back on is I don't actually think we should care about what the user nodes think about the network, because they're not actually they're not invested in the network. And that is obviously a philosophical difference, and that is what has caused the split. But to me, the only people that matter in the network are miners. In the case of Ethereum, they are very against that too, right? They think that much more like a democratic type network, I would prefer the capitalist miners competing. That's what I think that creates the perfect network. So,
Is Bitcoin Cash going to get like on-chain privacy, or is something called like oblivious transfers?
yeah. So there are a lot of different people working on that. People like Nchain have allegedly a patent to do that itself. The whole patent IP thing is a big controversial topic. There's something I just read that John Futbol wrote. I didn't read it too in depth. There's a few different proposals out there, but definitely need some work. But there are allegedly like there's someone working on right now having your address change every single block, things like that. So I really don't know too much about the specifics, but I can send you some like the proposals and that kind of stuff. It'll be interesting to see where that goes. Yeah.
You were talking earlier about an economic attack, or how Penny's was talking about an economic attack. You said it would take like $30,000 to make that type of attack. That's only true as long as the blocks are full, though, right? I mean, Bitcoin is very divisible. So if I want to create 100,000 transactions that are 8 Satoshis, I mean, if I have, like 6 Bitcoin, that should be perfectly fine.
Right. In the case of Bitcoin Cash, I meant specifically with 8 megabyte blocks, filling 8 megabyte blocks itself over a span of 24 hours would cost you about $30,000 because you still are paying for every single transaction. It adds up, and so.
What I'm saying is that each Bitcoin transaction is a number of bytes.
Right.
That whether I'm sending $1,000 or 10 Satoshis, it's still going to take up the same amount of space on the blockchain.
Right.
So why can't I create a whole bunch of very small transactions when the blocks aren't being filled, when the fees aren't even high?
Right.
I can spam the blocks and fill them with no fee or very low fee transactions, so it won't cost me.
It'll still, so in the case of, and I guess I should look at the exact numbers if you were to like really be, but I think that the people that did that attack were, I wouldn't even call it an attack because they paid money for it, really, honestly. But in that specific case, I believe that they were making, I'll have to follow up on the exact numbers, but I know that they weren't spending a lot of money either. They were still spending, minuscule amounts. But if you're doing that for 24 hours, that adds up. It very quickly adds up. And 8 megabytes is still pretty big when it comes to how many transactions you're making and things like that. But again, I would argue, and this is why I actually don't like the block size at all. I don't think the block size needs to exist because I think it's actually something miners should be in control of. So miners should say, if a miner wants to publish a 50 megabyte block, it's going to get orphaned because number one, the code can't handle number one, but number two, if every miner is just used to, let's say, 5 megabyte blocks day in, day out, whatever else, and you just throw a 75 meg block onto the network, the good chance that you're the only one that's going to be ready for that, and everyone's going to orphan it. I really think that what needs to kind of be taken away from it is miners really are the ones in control of the network. That a lot of people don't like that, and that's fine. Like I understand that argument, I guess. But if a miner wants to take the risk and publish a large block, for example, that's fine. That they're allowed to do that, but they have to understand. And this really comes back to kind of the economic game theory of the system. You're not going to do something that's so outlandish that you're concerned it might not make it into the blockchain because you're wasting a lot of time. You know what I mean? So, so in the case of, you're right. I would have to look at the exact numbers. Well, could you do it in $10,000, $15,000? I don't know. But
Well, I mean, I'm not even specifically talking about like the cost. Well, I guess what I'm kind of asking is, like, why is the cost as high as you're saying it is? Like, couldn't it be significantly lower?
I think it's the math way, because the transaction volume naturally is low enough on the blocks that there's enough of a gap to fill that 8,000. You need 10,000 or 100,000 transactions, even if they cost a tenth of a cent each. 100,000 transactions at a tenth of a cent is still $10,000, and it's the gap between what it naturally was filled at by the rest of the network and whatever you wanted to quote unquote spam or fill or whatever. Yeah, when you're needing to add 100,000 transactions to it, even at a fraction of a cent, they're going to add up.
Again, I'll look at the exact number, like how many transactions will fit in a block. I don't know off the top of my head, but I'm still it is pretty close to that number. Yeah.
So, moving back to this idea, I think you said you don't even see this problem if you end up with something like 3 mining pools that are essentially doing all of that.
Yeah.
So within this Bitcoin Cash ecosystem, each one of those is incentivized just to continue propagating as many transactions as it can or whatever. But what's the, if in 5 years or whatever, this is a developed ecosystem, I've got my own DApp and it's competing with some other DApp. And what's to stop me going up to one of those pools, or 2 of them, it doesn't really matter, and saying, here's $10,000, push my transactions ahead of theirs, right? No one's going to know, right? No one can sort of see, but because that, it's 1 of 3, it actually controls a huge amount of the pool. Is there anything that's going to be able to prevent that type of off-chain interference in the operation on-chain?
Yeah, so I guess 2 things. Number one, I don't think it will be 3. I think it will be bigger than that. I guess I just meant.
Yeah,
but you're right. Yeah. And so then another thing I'd say is that, do you mean like someone would say, here's $10,000, push my transactions through if you mine the block, for example? Or,
yes.
So I would say there's, I guess, 2 things to that, right? So number one, if you're going to do that, you're expecting them to be the ones finding the next block. So if you're paying that $10,000 just to hopefully they find the next block, and then they'll put your transactions in first, right? That would be one risk, I guess, you're taking of doing that. Or you could go, I guess, to all 3 of them and say, here's $10,000 each, right? If it's worth that much money to you. I would say number one, if there's no block size anyway, then all the transactions would fit in the next block if the miners are big enough to do that. And I'd also say number 2, I'd say it's probably the big one there. And if you want to spend $30,000 because those transactions are for whatever reason not important to you, or maybe you just want to screw everyone else, then
could you go over real quick, what you think the problems with the Lightning Network would have in the future?
sure.
So
I mean,
one of them was like civil attacks, right?
well,
because you had multiple hops. And
I would say the biggest thing and the most important thing to me is that the Lightning Network at scale, if it wanted to become a global payment system, would still need like 130 meg blocks, I think. So in some respects, I don't have a problem with Lightning Network. It's fine if people want to use it or whatever. To me, it just would be, well, if I can make an on-chain Bitcoin transaction for the same, if not less, then why not do that? And then I would also say, kind of going back to the mesh topology of it, if you look at the mainnet today, it's already a hub and spoke system. So all it would take is to DDoS a major hub, and you might shut down a lot of routes from person to person. Whereas, kind of in that graphic I showed, actually, it shows if a miner itself goes down. I'm not sure where it is in it, but somewhere in here, if the miner itself goes down, it doesn't really affect the network that much. It would come at some point. You can keep watching it, but yeah. So again, I don't have a problem with it. In fact, if Bitcoin Cash wants to put the Lightning Network on it, that's fine. I have a problem with crippling layer 1 to implement layer 2, which is what the core team has really done in the past. And the block's been full for a long time, so it's not like this just kind of snuck up with them. I mean, as I showed, since 2010, people have been talking about increasing the limit. I just don't understand the desire to cripple, Bitcoin adoption just to create this Lightning Network.
Isn't that kind of similar to hub and spoke topology?
No, because as far as transactions propagating across the network, this is really the network here. So if in a case of Lightning, so this isn't actually assume a hub and spoke model, but let's say if you had a node right here that was very well connected, I'm not just pull a picture of it, this isn't my laptop, but really you end up with a system where this hub is really well connected, this hub is really well connected, this hub is really well connected. So for the majority of things, your transaction you get from here to here probably has to go through maybe then, and then there. And so in the case of like, if one node here gets DDoSed off the network, I may not even have a route to there, or it might just, maybe I would still, but it would.
The spokes could, the hubs could communicate with each other, right? So wouldn't that
Right.
so
Yeah.
shorten the hubs?
But
Like, wouldn't it be similar to this topology of the other graph? I'm just saying.
you could, I guess, theoretically make a mesh network that was that well connected, right? But then in some respects, you're just recreating what Bitcoin has created with miners, right? I guess I see what you're saying, sure. But then how is that? What is powerful about that? What is powerful about building a mesh network that just has these centralized hubs that move transactions? Isn't that pretty much equivalent to what we have today? That's what I would argue. But
The difference is one would be off-chain and the
Sure.
other would be on-chain, right?
right.
That's the main difference.
Yeah, exactly. Yeah. So I would just say, why not use Bitcoin? That would be, I guess, my retort to that. But I can see both sides for sure.
I just want to make one comment. I think like the whole block size thing seems like more of a policy debate to see like how Bitcoin scales the best, more so than like whether 8 megabyte blocks are better than 2 megabyte or 1 megabyte blocks or not.
Right.
And it seems to me at this point that like mining is centralized enough in both networks that like it doesn't really make a difference to see that, because right now in Bitcoin you're putting the burden on the users to pay higher transaction fees. With Bitcoin Cash, you're putting the burden on the miners to buy better hardware if you want to have bigger block sizes. So it's sort of more of like what kind of an approach you're willing to take. And to me, it seems like more just an experiment on both ends to see which would scale the best.
Sure.
More of a policy issue. What do you think of that? Is it more of a policy issue or more of a technical issue?
Well, I think it's both. I think you're right. I think in the case of policy, again, I guess what would frustrate me is that you already had something that worked with regard to blocks were 10 kilobytes, then there were 20 kilobytes, then there were 100 kilobytes, and then it kept growing, right? So I'm okay with like calling it a policy debate, but it does seem irresponsible at the very least to say, well, 1 megabyte is too much, and therefore that's where it ends, right? I would still like, in the case of miner centralization, like, yeah, I see that point, but in the case of, for example, this isn't a good example, because Bitmain is an interesting topic with respect to Bitcoin. I think that you could take a good side on both of them, but really a miner becomes obsolete unless they keep reinvesting in the network. And so I think what you have seen is a lot of like, well, I'm going to vilify miners because they're really centralized and they have all the power, whatever else, which is fine, but like miners only hold as much power as they continually reinvest back into the network that you're using. So I'm kind of getting away from your question here. I agree, it is a policy question for sure. I just think again, it's a why did we cap it at 1 meg and not like, how is that the conservative? They say that's the conservative approach. It's absolutely not the conservative approach when Bitcoin lost half its market share to all these other altcoins because of that. You know what I mean? And so I would say the more conservative approach would be keep doing what we had already done. I guess I'll mention too, because I didn't really mention, if you have the wallet, you can sweep the wallet here by, if you downloaded a Bitcoin wallet, you can scan the private key. I don't know if maybe someone hasn't used Bitcoin before, but I put 50 cents in all of them. One of them had $2, but I might still have that one, so I don't know. Yeah, you can take Bitcoin Cash off there if you want to use it. You can even send it back to your public key on the left side, sweep it again from the right side, you can keep it as much time as you want. You can see how cool it is to like not lose any of that 50 cents as you do it. There might be more. If you have more questions, I'm happy to go.